The other questions asked about on homework number 1 for series was number 16. I wanted to look at that separately because it's a little different than some of the other ones. It looked like this, and you always want to apply the nth term test and see if n goes to infinity, do the individual terms approach 0. And you can see here, this denominator would go to infinity, the individual terms will go to 0. Okay? I think if you just start listing terms out, you're going to notice that it's not geometric in any kind of noticeable sense. So that kind of falls through, doesn't look like a geometric series. Okay? The thing that I noticed is that the denominator factor, specifically it factors as n plus 1 times n plus 3. Okay? I factored out the 2. Okay? And I just have to remember at the end of the problem that I want to multiply by that value of 2. I factored this as a over n plus 1 and b over n plus 3. I used the Heaviside method to find the missing values here. So oh no, you know what? I did not factor out the 2. I actually left the 2 in. Just kidding. Okay. Anyway, so I left the 2 in and I used the Heaviside method here. And anyway, what I ended up finding out was if I broke it up into these two terms, if I substituted in negative 1, 2 over negative 1 plus 3 is 1. That gives me my a value. If I subbed in negative 3 and cover up that term, I end up getting negative 1. And that ends up being the two terms that I end up getting. Okay? And so I just started listing out some terms and seeing what was going to happen. And I have to admit, this one was a little bit tougher than other ones I've seen. I had to think about it a little bit, but I think you'll still generally see the idea. The challenge is these are 2 apart. So you're not going to get cancellation quite the same way. So when n is equal to 1, you're getting a 1/2 here, okay? And then you're going to get a minus 1/4, okay? And then when n is equal to 2, you're going to get a plus 1/3, and you're going to get a minus 1/5, and then you're going to get a plus 1/4, and you're going to get a minus 1/6, and you're going to get a plus 1/5, and you're going to get a minus 1/7, and that sort of thing. And so anyway, you'll see that stuff does start canceling. Eventually, when you go out far enough, you'll see here that the negative 1/4 eventually will get canceled. But because these are too apart, it doesn't happen immediately. And then notice that nothing is ever going to cancel the 1/2 because you're never going to get a denominator that small here. Nothing is going to cancel the 1/3 because you're never going to get a denominator that small. Okay? But everything else moving forward should eventually get canceled, going down to the end. Now at the end, you go out infinitely, you go out to the nth position. Your last term would be a minus 1 over n plus 3, which isn't going to have anything to cancel because this denominator's never gotten big enough to catch it. Okay? There's also going to be a minus 1 over n plus 2 from the previous time you did it because these are off by 2. Those last 2 negatives won't get canceled. So everything else will cancel, but you have a minus 1 over n plus 2, and you'll have a minus 1 over n plus 3 if you extend it out. Anyway, long story short, as n goes to infinity, that's going to be negative 1 over infinity, which is going to go to 0, and this is also going to go to 0. So these final terms don't matter. Okay, so this series, telescoping series, you actually can find the sum. The sum should be 1/2 plus 1/3, which is 3/6 plus 2/6, which is equal to 5/6. Okay, so you can find the sum, but most importantly, this is a convergent series. Okay, it's a convergent telescoping series, which you can see by using partial fractions and breaking this thing out. Okay, relatively rare on the AP exam, but definitely something that comes up in Calc 2 courses.